All right, we're back. We are COMP123. That's programming 2 in the summer 2017 semester. And we are week 11, part 2 of our broadcast. We're still doing intro to LINQ and collections. We just finished off making our deck class. That's where we are. And what I want to do now is create the shuffle algorithm. The shuffle algorithm. All right. Now we got to think about how I'm going to do this. And what I want to do is I want to get a random value, right? And I want to loop through the entire deck and swap elements in the deck randomly with other elements. Woo! Okay, how the heck am I going to do that? Right? Huh? Could do that. So I need a for loop, yeah. That's what you're talking about. And let's try and do this right. So first of all, I need a shuffle method, which is going to be public. Right? I'm going to call this thing, it's going to return void. It's going to be called shuffle, right? And this public shuffle method is going to shuffle my deck. That's what it's going to do. Now, if you're using Java, and if I did the exact same code in Java, Java has a built-in shuffle method in their lists. I just go Java, like I would say this.shuffle, done, right? But unfortunately for C#, C# does not include a shuffle method, right? So I have to make my own. We have to make our own here, right? So we need a couple things. One requirement is somehow some kind of way of getting random numbers, right? And we also have to have an algorithm in our head of how to do stuff, right? There is an old guy. His name is like this whole idea of this Fisher-Yates. So this is Ronald Fisher, and it's a famous algorithm that you can look up. And what he does is he goes through and shuffles. It's a shuffling algorithm that goes through an array, and what it does, it takes position A in array or J, and swaps. This is the pseudocode, and swaps A with I, or I with J. Right, that's what it does. So I'm swapping the two, the two around. And now, in order for me to do that, I've got to be able to store the second value that I'm swapping in a temporary variable somewhere. So I'm going to take the first value. I'm going to look at the first card. The values of the first card, which is the face and the suit. Okay, I'm going to take those values, right? And then I'm going to look at the second card and take those values and assign them to the second card randomly. But what's going to happen to the values in the second card? They're going to be gone, right? I can't just assign them. I've got to save them somehow. So first I've got to save the second card, then assign the second card, the values from the first card to the second card, and then take the values from that's been saved in the temporary card and put them into the first card. Right? That's the shuffle, right? And I'm going to do it randomly 52 times, which means I could hit the same card twice, but who cares? I'm going to exchange in the loop. All right? So I need a loop, right? And the loop is going to be 52, because right now my shuffle is going to be card count. I don't know how big my deck is going to be. Maybe I'll have to shuffle again. And so therefore, my deck will have to be, I'm going to do a for loop, right? From, and again, this is the number of cards I'm going to be shuffling through, right? So I'm going to say card, right? And again, I might have done it differently in the first class. But where my length is card is less than this dot count. Yeah? Remember, because this is the collection I'm shuffling through, and this has a count, how big my collection is right now, right? All right, so I'm shuffling through the collection, right? Now, I'm not using a for each because I could use a for each too, right? If I want to. And if I was going to do that, by the way, it doesn't matter how I do it. If I go for each, right, it'd be the same thing, right? So for every card in the collection. But the problem with this is I don't know which one it is, and I want to go through it at least card length times, card count times, because I want to switch, so it makes more sense for me to use, in my mind, a for each loop, or sorry, a for loop, okay? So that's one thing. I need a for loop to go through all the cards, okay? Cool. Second thing is I need a random number, and the random number uses a random class, okay? So here's a random class. By the way, I might as well do this in here and say something like, in point 2, I'm going to add the shuffle method. That's what I'm doing, add a shuffle method. So in my random, I need some instance variables, and I'm going to do something like this. Private, the type is going to be random. You've never seen this before, probably, right? I'm going to call it underscore random, but it is a class, which means it needs to be instantiated. I need to instantiate an object of type random. I'm not going to do it here because this is an ugly place to do it, right? I'm probably going to do it in my initialize method. So this initialize method I'm going to redo, right? I'm going to say something like this. This builds the deck, right? That's what this thing does, builds the deck, right? Fills it with cards, right? That's what it does. And then, of course, I've got to initialize the random number generator. This is pseudo-random number, right? So I have to kind of say that that's what it is. It's not true random numbers, because, and there's different random numbers you can generate, but it's a pseudo-random. That's what it is. It's not truly real. So it's a kind of a, the way the random number generator works is it has a big list of pre-generated numbers. That's what it does. And you just go to the next one, the next one, and the next one, right? Yeah, pseudo-random number generator. Okay, so it's going to be like this. This dot underscore random, right, is equal to new random, right? Well, some people complain about this, right? They're like, wait, aren't you accessing a private instance variable directly? This is no good. Yeah, but I'm initializing, right? So it's okay. If I'm initializing, I mean, I'm creating, I'm setting values and all that stuff. It's okay to do that initialize method. Typically, we don't want to do this. And if you're really a stickler, you could create up here, instead of a public property, you could make a private property, right? You could do this too if you really want to. It's kind of a, I don't know, a waste, but let's show you how it works. I would do something like this. Private, instead of my property, it's going to be called random, and the type that it's going to return is random, right? Just random, right? Green, white, right? You know it's different. I don't need a setter because random is a reference type, not a value type, just like a class or a collection. And so I could do something like this, right? So I can get, and I'm going to return a pointer to this dot underscore random. So that would work. Okay, so that could be my private property, right? Which basically is like, it's only available to inside of my class, but not available outside. And it's still a property, which means I could do something in here whenever I set or read a value. I could do something whenever it's accessed, right? That's what it's for. Type safe. Okay, cool. So I've initialized my random value. That's cool. And now I got to use it, right? So down here in my shuffler, I'm going to say something like this. So I need a couple things here, right? Some local variables. I need a first card, I need a second card, and I need a temp card, right? Let's check this out. So here we go. So here's my first card, and the type of first card is it a card? What am I really doing with my first card? It's actually an index, right? So first card is an integer, right? And second card is also an integer. So here's second card. I want to get you can call this a first card index or second card index, whatever. I'm going to call it first card and second card. So what I really want to do is something like this, right? I want to say that, well, and this is really funky. Watch the syntax. This, right? Open square bracket, because this is a collection, right? So I can do this. This, notice what the syntax it tells me. It says, I'm looking at a card in the index in my collection, right? So the card that I'm looking for is the second card, right? I can go something like the second card, right? And I want to look at the face of the second card, and I want to make it equal to the first card, right? And then dot face. That's what I want to do, right? Okay. Now it says use of unassigned local variable second card, which means I didn't name this properly. Second card. Did I do something wrong? Use of unassigned integer. Oh, sorry. So I need to get the value for second card and first card somehow, yeah? And I'm going to do that up here. So I'm going to say something like this. Well, in the beginning, I'm going to say first card, right, is equal to, and here is the random, this dot random, right, dot next, and I'm gonna get a value. There's 3 different constructors for the random, right? There's nothing, the empty constructor. There's a maximum value, and there's a minimum to a maximum value. That's what I want. So I'm gonna go from 0, right, to 52, right? Not including 52, but hold on a second. Remember, 0 to 52 doesn't mean anything. I mean, I could put in from ace to king, right? I could put that in there if I want to be a stickler. So just if you want to do this the right way, I mean, I know it starts at 0 to 52, right? And I could do that. I could say something like, so int face dot ace, right? That's the first card. To int face dot king. I know that's the last card. So for every card, right? But hold on a second, that doesn't work because kings only go to 13 and aces start at 0. So that doesn't make any sense. I like it, but the idea in my head, but it's not right. I'm just showing you that you could try and think of ways of making it more readable. And it doesn't make sense in this case. So we're just going to put 0 to 52. All right, and I'll do the same thing for the second card. So I'm going to say first card, and here's my second card, right? Because every iteration of my for loop, here's my second card, right? I want to get a random number, and that's going to be a random index. Where am I looking in my deck? Am I looking at the top card or the bottom card? Okay, well, which card am I looking for? And now this swap here, this swaps the card, the face from my second card to my first card. But that's just the face, and I got to do the other one too. I got to say this dot, second card, right? Dot suit is equal to this dot first card dot suit. But I got a problem, right? I can't take my second card and put it to my first card because I'm overwriting it here, right? What I really want to do is take the temporary card, store my second card in a temporary card. But man, this is really cumbersome, this thing. I'm doing 2 commands here. Wouldn't it be nice? And whenever, by the way, hint for me, if you ever program with me again, whenever I say, wouldn't it be nice, it means I'm missing something. I need something. I need to modify an existing class and add some behavior, right? That's what it means. Wouldn't it be nice if I could clone the card? Wait a minute. Didn't we talk about this iClonable interface last week? We didn't implement it, but we talked about it. Let's do it. So in my card class, I'm going to implement the iClonable interface in my card class. So I'm going to go here, right? And I'll say implemented the iClonable interface. Okay, well, what does that look like? It looks like this, colon, and then iClonable, right? That's what it looks like. Look, iClonable, right? But now I can implement the interface like this, right? Here's my interface. Now, this is a public interface. So I'm going to or public methods. I'm going to take this and put it down in here, right? By the way, I knew I was going to do this because I did it in the first class. I'm going a little faster. And I'll say this method overrides, I'll put the comments in there, the built-in iClonable interface. Built-in clone method, built-in or clone method. Okay, so here's clone, but I got to implement this. What do I want the card how do I want the card cloning to work, right? Because notice it says I have to return an object, right? How do I do this? Well, here's how I do it, okay? I'm going to do something like this. I'm going to say, well, the card itself, I want to return, right, an object, which is a new card, right? And the card is going to have this dot face and this dot suit. Does that make sense? So I'm returning an object. Now this is going to be a problem. We're going to have to recast the object that I'm when I clone, I'm going to have to recast this object as a type of card, right? Does that make sense? The reason why I'm returning a new card, I'm actually creating a brand new card that I'm returning. I'm making a copy of what's actually in this card right now and returning it back out. That's what I'm doing. And actually I put it in the wrong space. It should be under public methods, not private. So it should be down here. Just moving it around. I know it's comments, and who cares, but I really want to do it right. Cool, so this is done. Here's and I could make a commit now, but I'm not going to yet. I'm going to go back to my deck class. Here it is. And now this is what I want to do. My temp card, take a look at this, is going to be a type of card, right? It's going to be called temp card, right? But instead of instantiating a new object, I'm just going to make a clone of my second card. So I'm going to do one of these. I'm going to go to temp card is equal to this dot, or this second card, right, dot clone. Now, when you look at this, it says, hey, I don't understand what you're doing. I'm getting some weird object back because clone returns an object, but we want an object of type card, so we're just going to cast it. All right, so what this is doing is first I'm getting two random values. Then I'm going to take the second value, clone it, and create a new object called temp card, which is actually a card, a brand new card. Think about it in real life as somehow before I'm actually not shuffling, I'm actually writing the values down on a new card. And then I'm taking that card and putting it into the deck. I'm taking the other one and ripping it up. That's what I'm kind of doing, right? But I'm doing that new card. I'm creating this new card on the fly. Every iteration, every time the for loop goes, I'm creating and destroying a new card. I'm creating a card temporarily, writing the values in there, and then when it comes back, I destroy it and make a new one, right? Okay, cool. Now this is the first part. I'm assigning the face and suit of the first card, and I'm assigning it to the second card. Whoa, all right, wait a minute. But I got this clone capability, yeah? And instead of doing all of this work, face and suit, and I didn't do this in the first class, but isn't there a way of cloning my cards anyway? Right? I mean, hey, look, I've got my temp card. Can't I clone the first card and put it in my second card? Like my first card is itself. I've already cloned my second card, right? Can't I clone my first card and make it equal? Well, because second card itself, the space, this second card itself, is actually pointing at an element in the list, right? If I create a new random card and point it to it, I could do that. I could actually point it in there. And maybe we'll do that next day, but instead of confusing the crap more out of you than I am already, right? Let's just do this. So this first card dot face is equal to temp card, because my temporary card is what's holding everything, dot face, right? From my second card. And this first card dot suit is equal to temp card dot suit. So this is my swap, guys. So first I create a space for my temporary card clones the second card, whatever that second card is, right? It basically creates a new card for me to, it's like a holding space temporarily. And then I take the value of the second card, right? And I assign it the value of the first card. So whatever the value of the first card was, the value for face and suit, I assign it to my second card's face and suit. Okay, cool. Now I take whatever I stored in the temp card and assign it back to my first card. And now I've done the swap. That's what I'm doing. I'm swapping one card for the other card. Okay. Now this algorithm, this Fisher-Yates shuffle, right, is a very classic algorithm. And guys, in an interview, you guys should know how to do it. I'm not joking, right? This is like basics, right? If you can't shuffle two objects in an array or a list, problems. Okay, you need to know how to do that, right? That's why I'm introducing it to you. Okay, cool. So I've shuffled the cards. Yeah, Tom, I mean, I think it's working. Yeah, I don't know if it's even going to work. We need to test it somehow. So let's comment. Right, so this method shuffles the deck by using random indices. Indices? I can't remember how to do indices. Yes? Come on, I can't remember. I'm really, this is a big fail. Indices. Yeah. Indices. That's right. That's what it looks like. Indices. Yay. Indices. All right. So indices. So random indices to select 2 cards at a time. Okay. It uses a Fisher-Yates like algorithm. Not quite Fisher-Yates, but very close. The idea behind it is having this temporary card is what we're doing. Okay. All right, let's see if it works. So I'm going to control, first of all, we have to go to our program, and I'm going to say I want to test the shuffle method. So that's the thing I'm going to do here. So test shuffle method of the deck class. So it's going to do here. And the way it's going to be done is I want to print it out, do another console write line, right? And then do a deck.shuffle, right? And then a console write line with the deck.toString. Now, just to make it a little bit nicer, we'll do, and this is something I didn't do in the first class, is I'll say original deck, right? My original deck there, maybe some kind of separator. So, like that. And then we'll do the shuffle deck. So you can see the difference between one and the other. So deck shuffle, and then we'll do the shuffle deck. Okay, does that make sense? So bit of separation, right? And if I press Control F5, we should see everything work like so. Let's check it. So here's our original deck, right? Ace of clubs, 2, 3, 4, 5, and so on. Diamonds, hearts, and spades, right? All the way to king. And now take a look at my shuffle deck. 3 of hearts, 3 of diamonds, 10 of hearts, 4 of clubs, jack of diamonds, all shuffled. Now look, remember this, 3 of hearts and 3 of diamonds. Let's do the shuffle again. Let's run it again and see if I get the same results. That's important. Okay, so 3 of diamonds, 3 of hearts. Hold on. What's happening here? Wait. 9 of spades, 7 of spades. Whew. That was weird. Let's try it again really quickly. 2 of hearts, 5 of spades. Right? See it? See what's happening? So it is shuffling. And sometimes what happens is you might get some weird stuff like ace of diamonds, 10 of diamonds, 2, 4, 5. So this is kind of neat, right? And sometimes what we want to try and do is implement this whole idea of a double shuffle, right? Where we do a extra random thing, right? But this is enough. All right, let's put this up on GitHub. So I'm going to say I modified, did a bunch of things here, but the main thing was in my deck, I implemented this shuffle method, right? That's what I did here, and that's what I said I did. I added the shuffle method to the deck class. So I'm going to do that. I'm going to go to my Solution Explorer, Team Explorer, Home, Changes, Added, shuffle method to the deck class. Middle, home, sync, and push. All right, I need questions now. I know there's going to be questions for this one. What the heck did I do, right? And how can I do it if I was going to go if I'm going to I'm going to refactor this thing. I want to make it more effective. I want to use clones to do this instead of this face and suits. How can I do it? Because remember what I'm looking at, and this is where it's a little bit confusing. When someone saw this and then these square brackets here, they're like, wait a minute. How can you use this as the square brackets? Well, I can in this instance because this is pointing to my deck class. My deck class is a collection of type list, which is of type card, a card list. And so the square brackets work because if I hover over them, you can see that when I point to this, it means that the deck, this points to the deck itself, right? And the square brackets actually point to a location inside of my list, right? A random location that I'm getting from, it's an random integer between 0 and 52. I only have 52 cards, right? Okay, but this is a problem. I know I need to redo this because I'm making a random value between 0 and 52. But what if I take a card out of my deck? This wouldn't work. And this, I didn't have a chance to do this in the earlier class. So 0 to 52 is great, but it shouldn't be. It should be 0 to card count, right? To my deck count. So that's what it should be. So right now, the count, if I want to see how big it is, right? How big is count? 52, right? And so too would this be. And what I'm doing is I'm getting a random number every time. They're going to the next value, right? So this should be more flexible and not go to 52, but rather this dot count. Because what if tomorrow I remove a card, which I'm going to do? I'm going to shuffle. I'm going to deal, right? And dealing is going to take the top card off the deck, right? So that's definitely something we need to do. So I'm going to go up here and say, so now I'm going to do more than one thing. And by the way, I'll do this with the other class next day, right? Because I need to do that. My other one is a little broken. I didn't have a chance to finish it. Right? So I'm going to go up here and say refactored, shuffle method, right? That's what I'm doing. So that's the first thing. I changed this piece. And now we have to test it. Once I make a change like this, I got to test it. So let's test it. So Control F5, and looks like we're good, right? You know, it'd be nice if I knew how many cards are in my deck when I shuffle. So maybe we should add that in. So far there's 52 cards here, and there's 52 cards there. Let's see if I can shuffle when I shuffle, or even when I print out anything in my two-string, right? I want to know how many cards are in the deck, right? So maybe what I want to do is, so maybe I'll put it in my program for now. And I want to say this many cards per deck. So original deck. And then I'll say, right? Something like a couple spaces, number of cards, and then plus, and then deck dot count, right? And I'm going to do the same thing here with my shuffle deck, right? Should have 52, right? In both cases right now. So let's try this out. So Control F5. So original deck, 52 cards, right? Shuffle deck, 52 cards. This is important, right? And you can see that if I wanted to count them, I could. Looks a little shy. Doesn't look like 52. I can't tell, right? So clubs to 13, diamonds to 13, hearts to 13. It looks about right. In a further test, in a bigger test, I'd want to number them, like number 1, 2, 3, 4, 5. And that's not difficult to do, right? You could do that in your toString method by just putting, you know, every time you loop through, you know, the toString method, just print out a number 1, 2, 3, 4, 5. You know, and that might not be a bad test. We can always remove that later. But inside my toString method of my deck here, in my output string, so I could put the number, like a number, whatever. I could make a counter somehow and put a number before this. I'm not going to do that here. All right, so what I want to do here is, before we end for the day, I want to figure out can I use the clone method? I just made this really cool clone method. Can I use the clone method somehow and somehow make it so that I can clone the card and replace the card with something else? This is something interesting. So if I clone the second card, right? So I find the first card, or the second card, I clone it. Find the first card, I clone it, right? And then I want to say that my first card is equal to this new random card, and my second card is equal to this new random card, then destroy the random cards. That may not work, right? That may not work, right? Because I'm creating new cards, right? Whereas opposed to I'm using this temporary card. So wouldn't it be a neat way of copying? And the way to do that, of course, would be I need to make the overload the equals operator, where I can say one card is equal to the other card. So this operation here that I'm trying to do, right? And I want to do from one to the other, okay? So I want to say like card 1 is equal to card 2, but where am I doing this? I'm actually taking a card face and I'm equaling it to another card. But what I really want to do is I want to say one card equals to another card. It's not like cloning. It's like one card equals another one. That means I need to make the equal and not equal operator. And I don't think I'm going to have time to do that. But just to give you a hint of what to do, I definitely would not do it in the deck class. It'd be in my card class, right? And remember how we did that last time, right? We make them public methods. It'd be something like this, right? I would overload, right? Public static, right? And what's the return type? Come on. Is it a bool? I'm equaling, right? Greater than returns an equal sign, right? Greater than returns a Boolean sign. An equal operator returns void, right? Or does it? Is it equal or equal equal? Can I even do the equal one? What are the operators that I can overload? Let's go back to that one, right? So operator overloading C#. Can I even do it? How about that? I like the idea behind it. What are the operators that I can do? Not tutorial. It's a tutorial. I don't want a tutorial. I want to know the operators. I can look at the other PowerPoint. But I want to know, here's the operator true and false, right? Here's the and, here's the not, here's the double equals. That's equal equal. But I want to make, can I do the assignment operator somehow? I can't, right? Assignment is not something I can overload, right? Nice try, Tom. Right? What else can I do? Is there another way I could do this? I mean, I like the idea of operator overloading, because I want to make take this one card and make it equal to the other card. But I can kind of, right? It's a pointer. Whenever I use an equal operator when I say one card is equal to the other one, I can do that, but it's going to point to the other one, right? Right? So really all I need to do is set the pointer to the new card, right? So this one equals to that one, right? But will that mess up my list? Will that actually shuffle my list or not, right? So that won't do it. I could say swap. I could make a new method called swap. I want to swap. It could be a public static method where I swap one card with another. I have two cards, right? Two cards, and I card 1 and card 2, and I swap card 1 and card 2's values. I could do that. Here, let's do it. So public static returns void, right? And I'm going to call it swap, right? I'll swap one card with another. It takes two cards. So the first one is of type card. We'll call this first card, right? And another card. second, right? Oops. Right? And what I want to do is I want to take my first card and equal it to my second card. Hold on. If I swap my first card and my second card, am I not doing the card operation in the first place? Like the Fisher-Yates shuffle? That's what I'm doing, right? Taking the first card, swapping with the other card, right? And what happens? I almost do half of the operation here as it is, right? It's almost like I don't need a clone, right? I don't need to clone because I just swap. I take my first card and swap it with my other one. Whatever my first card is now is my second card. I could do that here, right? But that's not the effect that I want. It's almost like I want the first card to equal the second card. I want to assign, like card assign, or, you know, I don't know, something like that. We got to think about a name. Can anyone think about a name to use? Not a swap, but a, you know, kind of like a, it's like another clone. That's what it is. It's like a clone operation. But instead of me cloning the card, right, where I create a new card, I actually just copy. Hey, there we go. Card, copy, right? Different than clone. All right. All right. How does card copy work? Well, card copy works like this. I take the first card, right? Whatever the value of the first card is, I take it and put it onto the second card, or the other way around. So first card, so second card dot face is equal to first dot face, and second dot suit is equal to first dot suit, right? And I don't care about the other one. My second card, the value of my my second card is destroyed, right? Because I'm just going to take one card and copy it over, right? We could say, you know, copy over or over copy or something like that, or whatever. We can think of the name, right? I might think of something else later on. For now, we'll use copy. And what does this do? And that's why it's important to document. This method takes the properties of the first card and copies them and overwrites the properties of the second card. You know what? Overwrite. There we go. See, I'm changing my mind over and over again. Overwrite. There we go. Overwrite. Overwrite. And again, the second with the first. Again, you might say, well, aren't you saying overwrite first card with second card? You know, and if that's the truth, we'd have to mix these around. But for now, we overwrite the properties of the second card, right? Take the properties of the first card and overwrites the properties of the second card. Guess what it does? Yay, overwrite. And since we did that, we added the overwrite method. Right, that's what we did here. All right, and let's go back to our deck. Now we've got a solution, right? Because now I can do something like this. I can say, well, I've got my second card, right? And I want to overwrite the values, my first card. So it'd be something like this. Instead of these 4 lines, I can cut it down to 3 or 2. I'm going to say this second card, right? Now, it'd be like this. The card dot overwrite, right? And then this second card with this first card. And you know what? I just figured out that it's the other. It should be the other way around. So we're going to fix that in a second. First card. So, okay. So go back. It should be the other way around. Just because it's natural to say, take the second card's value and overwrite the first one. So it's the other. This is the other way around. So it's like first card, first face, And first suit is equal to the second face, second suit. Sorry. Makes more sense. Overwrites the properties of the first card. No. This method, right? Override. This is where you don't, where you haven't scripted this, and it's just, you're just randomly doing it. This method overwrites the first card property, first card with the second card. I want to do. Okay, that's nice and sweet, and maybe someone will understand. Okay, and so that's what I want to do. So I'm going to overwrite the first card, whatever it is, with the second card, right? So this one is going to replace this one. That's what I'm saying. Okay, and then I'll do the same thing with the other one. So I'll say now I'll take card dot overwrite, right? This first card. And the other card that's going to be there is the temp card. Right, that's what it does. So it's going to overwrite from one to the other. Now I get rid of all this. Right? And it makes more sense. It looks nice. Looks nicer. And it's more, even though it looks smaller, it's not really that small because I put some of the code in another method, but now this method looks nicer. Right? Because you can read it. Overwrite this card with this card. Overwrite this card with this card. Right? And now let's see if it works. Who knows? Nice thinking, Tom, but who knows if it works, right? Test. It looks like it. King, 9 of clubs, 50 cards, 10 of spades, 10 of cards, jack and king. Okay, let's do it again. It looks kind of looking pretty weird. Ace and, yeah, okay. Yeah. Questions for this one? So basically what I did here, I'm gonna put this up on GitHub for you guys. So what I did was I refactored, right? So I'm gonna go to changes, and I did refactor the shuffle method of the deck class, and I also added some other stuff. Again, you would probably break this down into more commits, like I said, because I did a bunch of things at once, right? Okay, that's it for today. Remember, next day, so that's Thursday, I will have a lab that's based on the stuff that I'm doing here with you guys today, right? And we're going to be, hopefully, I'll get to do some user interface at the end. Chances are, looks like not, because I've focused a lot on this whole list stuff, right? But now think about what I want to do with LINQ. I did the list stuff, a bunch of list things, and I want to touch LINQ. And so think about what I want to do. What if I wanted to search for a card in the list, right? How do I do that? How does it return, the highest cards in the list? How can I do that? Or if I have a hand, think about what I want to do. I want to do card shuffling and card dealing, right? And I want to deal 5 cards, right, to a person. So out of those 5 cards, I want to find the card with the highest value, right? And I want to get all the cards with the highest value, and I want to sort them. Right? How would I do that? It's very difficult unless you have LINQ. And that's what I'm going to do next class. Okay? Think about some kind of shuffling, sorting algorithms that I can do with this stuff. All right? Any questions before we go? Yeah, that's a good idea. Let's take a look at the class diagram. It's very interesting what we've done, right, with this one. If you look at it, even with the card class, notice that the card class now implements the iClonable interface. That's neat. And the card class is a little bit fatter, right? Because I've got this overwrite method as well as the clone method. Clone does one thing, and overwrite does something totally different, right? Clone creates a new card, where overwrite actually takes one card's value and overwrites the other card's values. All right? All right, see you guys next week. Thank you. Or next day, Thursday. Remember also that Friday is when your assignment is due, Friday at midnight.